So myself is Jaimin Sanghani from VVP Engineering College. Myself is Jaimin Sanghani from VVP Engineering College. Uh, Now we have concentrate VVP Engineering College Rajkot Electronics Communication Department. Now we can concentrate on the other parameter of the operational amplifier, which is known as CMRR, PSRR and slew rate. What is the meaning of CMRR? That I would like to explain here. What is the meaning of CMRR? Ability to reject common mode signal common mode signal inside operational amplifier successfully. So it is known as common mode rejection ratio. It is known as common mode rejection ratio. Now, 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 CMRR equal to AD divided by AC. AD means what? Differential gain divided by AC means what? Common mode gain. Common mode gain. Here it is known as differential gain. So CMRR means AD divided by AC. Differential gain divided by common mode gain. Now it is the basic definition. It is the equation that you have to write in the examination. Now, what is the meaning of common mode gain? Common mode gain means what? If I have applied, see here minus terminal, please in examination carefully write plus VCC minus VEE very carefully. Otherwise you will lose the mark. See this can be considered as a both input, and here AC source that can be applied as an input to the both terminal. So here we can get V0 equal to 0. So here it is known as common mode gain. Output which is equal to 0. Why? Because common signal that can be applied to the inverting terminal and non-inverting terminal of OpAmp. Common input that can be applied to inverting and non-inverting terminal of OpAmp. Inverting terminal of OpAmp. So it is common mode gain. It is common mode gain. Now, ideally it is output is 0. So if you can put the equation in the CMRR, see the CMRR, which is equal to AD divided by AC. AC which is tends to 0. So ideally CMRR would be infinite. So I have right here topic continue, which is known as CMRR. Ideally CMRR tends to infinite, and practically it should be 90 dB. CMRR measure in the decimal value. So practically it should be 90 dB. Ideally CMRR tends to infinite. Now, what is the meaning of differential gain? See this. What is the meaning of differential gain? Here it is known as plus VCC. Here minus VEE. Negative terminal, positive terminal. Here we can say V in 1. Here we can say V in 2. So what is the differential gain? V in 2 minus V in 1. Subtraction of non-inverting terminal voltage minus inverting terminal voltage. So here whatever gain we can get, V0 divided by V in 2 minus V in 1, which is known as differential gain, which is known as differential gain, AVD. Differential gain, and ideally differential gain which is infinite. Sorry, ideally differential gain we can get some value. So CMRR ideally infinite, and practically it is 90 dB. So it is the complete explanation related to CMRR. In examination you have to write this particular portion. See this. See this. This part and this part you have to write in the examination. This is just for explanation. Ideally CMRR infinite, practically 90 dB, that you have to write in the examination. Now, after completion of CMRR, one of the main topic which is known as, after the CMRR, one of the main topic which is known as PSRR, which is known as PSRR. PSRR means power supply rejection ratio. Power supply rejection ratio. Now, what is the meaning of that? It is defined as output voltage present in the circuit due to variation in power supply, either plus VCC or minus VEE. It is defined as output voltage present in the circuit due to variation in power supply, either plus VCC or minus VEE. Due to power supply, what is the variation in the output voltage? It is known as PSRR, delta V IOS divided by delta V. offset voltage divided by supply voltage, which is known as PSRR, and ideally it is equal to 0, and practically what is the value of PSRR, which is equal to 150 microvolt. See this. It is the ideal value of PSRR, power supply rejection ratio. Now next, which is known as power supply rejection ratio, CMRR, and slew rate, one of the most important parameter. With respect to time, what is the amount of voltage, what is the amount of voltage that can be changed, in the output side. So it is known as slew rate. Per microsecond, output voltage is changed. So S equal to change in output voltage with respect to time. So dV0 divided by dt, and what is the unit of that? Volt per microsecond. S equal to dV0 divided by dt, which is known as volt per microsecond. And ideally, infinite slew rate. And what is the practical value? 0.5 volt per microsecond. Per microsecond, 0.5 volt change. Now see this. If in open loop configuration, if I have applied as an input like that, now we can get output. Here V in input, here V out output. See this. See this. Per microvolt. See this. This is the 1 microvolt, 2 microvolt, 3 microvolt. Per microvolt, output voltage suddenly change. So it is the concept of slew rate. Ideally infinite, practically 0.5 volt per microsecond. So it is the concept which can be leads towards the slew rate concept. Thank you.